Well, hey everyone, my name is Dr. Dan Grissom, and in this video we are going to take an in-depth look at the hash map. So before we really start coding anything up in Java, let's first take a look at a conceptual view of a hash map, what it really is and how it works at a high level. Okay, so typically I think of a hash map as a table with two columns. And what's really neat about a map in general is that we can map any arbitrary data type to any other arbitrary data type. So if you think about an array, for instance, what do you have? You have a number of cells that are storing maybe a number of strings or a number of integers. And you have these indices, right, from 0 through the size of that array. And so in some sense, if you think about it, with an array or an array list or anything along that lines, you are mapping an integer, that index, to some piece of data. So if you have an array of strings, then you're mapping an integer to a string. So int I equals 0 will get you a certain string in that array, the 0th item. If you have I equals 10, then you're going to get the 10th item, or really the 11th item, if you think about it being a 0 base index. So with a map, we can map anything to anything, which is a really powerful feature that we'll see as we tease out this example and then we start to write some code using hash maps. So a few properties. So remember, a hash map you typically think of as a two-column table with a key and a value. One property that's really important to understand is that keys are unique. Okay, so I can only have what we're going to do is we're going to add a bunch of desserts to our hash map, and we're essentially going to map dessert type to the number of people who have said that dessert is their favorite dessert. So I can only have brownies once in my map. I can only have cookies once in my map, and I'm going to change that number from 1 to 2 to 3 or whatever as more and more people say that is their favorite dessert. Okay, so another property that we'll see once we get to coding specifically is that these key value pairs are unordered. Okay, so you'll see that they just basically get added in here somewhat randomly. So let's take a look at a small sample code snippet here. So what you'll see here is I have this map and I'm defining what my key and value data types are. So what I'm saying is I'm mapping a string to an integer. Okay, and specifically I'm going to map a dessert to the number of people who like that dessert. Okay, so I say map string integer with the two data types of the key and the value equals new hash map, and then you can see the same thing, string integer. Now notice I have hash map over here instead of map. This may be a little bit different for you if you're new to Java, having one data type on the left hand side of the equal sign and then another data type on the right hand side. But essentially what's happening right here is map is an abstract class. Okay, it's an abstract data type. So I can't actually instantiate a type, the map data type. Instead, hash map is a specific implementation of the map, and we'll see there are a number of popular implementations of the map, but hash map is typically the best because it's typically the fastest. Well, it is the fastest. Okay, so we'll come back to that. We'll revisit all of that at the end, but for now, just kind of take this syntax for what it is. I'm creating a new map, and specifically I'm going to use the hash map implementation. Notice that there are two parameters for this constructor. So I'm passing in a 4 and a 0.5. These two parameters correspond to the initial capacity of my map and then what's called the load factor. Okay, so the initial capacity is how many rows, if you want to think about it as a table, how many rows of data can I store? How many key value pairs can I store? So in this case, you can see that I created a map with size 4. Okay, I can store 4 different key value pairs. The load factor says essentially how many items can I add before I need to double the size of my map. Okay, so just like an array list that dynamically resizes, a map is going to do the same for me. So essentially what I'm saying here is once the map is greater than 50% full, then go ahead and increase the size. And in fact, we'll actually double the size. Okay, so let's go ahead and run our first line of code. You'll see the simple methods that we're going to do are just put, replace, and remove. Okay, now there's a number of different methods that we're going to dive into once we get into the code, but these will show you how a map actually saves key value pairs and expands as well underneath the surface. Okay, so in my map, I'm going to put cookies with a value of 1. Now notice, one thing I want to point out is it didn't put cookies in the very first row. It just kind of picked a row. Okay, so a hash map has a lot going on underneath the surface, which is beyond the scope of this particular video. This is more of a data structures topic if you want to know really how the map works underneath the surface. But the thing to understand from a functional standpoint is with a hash map, there is no order. Okay, it has an internal order so that it can access its data very quickly. But to the programmer, it will look kind of just out of order and chaotic. So anyway, it puts cookies with the value of 1 just in some seemingly random row. Okay, so then we'll go ahead and put brownies with a value of 1. Okay, and then if I tried to put brownies again with a value of 3, what it will actually do is it'll just overwrite that value that brownies already had. Okay, and again, the main thing I want to emphasize here is that the keys are unique. So if I try to add brownies a second time to my map, it's just going to overwrite the brownies value that was already there. Okay, so let's say that I go ahead and I now try to put pie in there. Okay, so pie would be my third item in the map, and 3 out of 4 entries would then be full, which would give me a 75% load on this particular map when we still had 4 items. So at this point, this is where this load factor kicks in, and it essentially doubles the size of my map. Okay, so I can then go and I can replace cookies with 2 if I want. I can put candy at a value of 1, and then finally I can go ahead and remove a value such as pie. And what that'll do is you can still kind of see it here, but this would literally remove this value from the map. Okay, so at this point, let's go ahead and jump to some code. All right, there we go. So I have kind of a template file set up for us to get started with, and I want to basically explain what we're going to cover in this coding example, and then I'll walk through the very simple code that I already have set up, and then we'll kind of go from there. Okay, so we are going to, again, specifically we're looking at the hash map. All right, so all the functionality that we see is going to be true for a hash map versus some other type of map, just as a FYI, but we are specifically creating hash maps. So it's more comes down to the underlying implementation as well as the speed. So hash map will be the fastest for us. Okay. So anyway, we're going to work with several different types of constructors. So we're going to look at a number of different methods that you will use commonly with maps, such as the put family of methods, so put and putIfAbsent, the get family of methods, getOrDefault, the compute family of methods, compute, computeIfPresent, or computeIfAbsent, and then a number of other methods that you really can't not know when you're wanting to use maps. So replace, remove, ContainsKey, and KeySet. Okay, and then what we'll see is we're going to do 3 different methods of iterating through maps. So you're going to get a really good understanding of the key methods that you really are going to want to know when working with maps at all. Okay, so what does this code do? So far, all this code does is we just are creating a scanner. And then you can see we have this do while loop that's simply asking the user to please enter their favorite dessert. They enter the dessert. And one thing I will point out is we actually uppercase this dessert, and I'll explain that a little bit later. So if they type in cookies undercase, it's going to uppercase it. And then we do some stuff, we'll talk about that in a second. But this do while loop, it just essentially asks them, hey, do you want more desserts? Yes or no? And if they say yes, we're going to convert that to a true, and we'll loop around again. So if we run this program, I could type in cookies, yes. Brownies, yes. Pie, no. And then you'll see that the program will end. Okay, so essentially what we are going to do, the functional purpose of this program is to create a program that will essentially map the favorite desserts. As we basically keep asking people what their favorite dessert are, we're going to map that dessert type to a counter, which counts the number of times that particular dessert has been seen. Okay, so how are we going to do that? Well, we are going to use a hash map. And in our hash map, we're going to map desert types to a count, or a key to a value. So another way to look at that would be that we're mapping a string to an integer. Okay, so we can look at it using these three different terminologies. Okay, so we're going to create a hash map. And then in our do while loop, as they are entering in a desert, we are going to update the map, just like we were seeing with the slides behind. The actual updating of the map, we're going to write the code for that right in here. And I'm going to show you three different ways to do it using a combination of these different methods that we talked about. So we'll get to those in just a little bit, but I want to show you different ways. You may have a certain preference or a certain need to use a combination of these methods, so I just want to make sure you understand all the possibilities that you have at your disposal. Okay, so once we've updated the desert count, we're going to print out all the desserts with the frequency, and so that's going to be iterating through the map. Then we're going to prompt the user to get to access a specific dessert count, and then we're going to prompt the user to remove their least favorite dessert, and then we're going to print all the desserts after the one dessert has been removed. We'll make a copy of all the desserts, and then we'll iterate and print all of those out one more time. So down here, we're really practicing all the different ways to iterate through our map. Okay, so let's get started. All right, so the first thing I need to do is I need to create a map, and I need to pass into these angle brackets the data type of the key, which is going to be a string, and the data type of the value, which is going to be an integer. So remember, we're really mapping a desert type to a count, which is a string to an integer. Okay, one thing to point out with Java, anytime you have these angle brackets where you're giving a data type, you can never do the primitive data types, the int. It's basically expecting some type of object. So make sure that you do give it the integer with the big I. So I will call this mDessertCount equals new, and I want to say new hash map. The particular implementation of a map that I want to use is a hash map. Okay, and I'll say string integer. Okay, and I'm just going to do an open and close parenthesis. Okay, now make sure that you need to import these two data types. So map, you want to import that from java.util, and then hash map you're also going to implement from java.util. So if you're in Eclipse, you should be able to hover over those and automatically add them. If you're in another editor, you might need to type these out from scratch. It's just those two, java.util.hashmap and .map. Okay, now this is the most common constructor, and this is the constructor that I use. Okay, but there are three other constructors that are also usable. So I'm going to show you those constructors. I'll just copy that line, and I'll make a dessert count 2 and a dessert count 3, so we avoid those errors. The other two constructors, the second one takes in one parameter, and the third one takes in another parameter. I'll use the values that I was using in the slides previously. Okay, so this is the constructor that we looked at in the slides. It takes in an initial capacity and then the load factor. Okay, one of the constructors just takes in an initial capacity, and then the third constructor here takes in the initial capacity as well as the load factor, as we discussed in the slides earlier. So there's also one more constructor, and we'll dive into this one a little bit later, but the fourth constructor takes in essentially another map, so something like mDessertCount3. And that's basically going to be an existing map to copy. Okay, so these are the four different constructors. We're just going to stick with the first one. So I've found in practice, there's really typically no reason, unless you're really getting to some kind of odd high performance situation, where you really need to customize the initial capacity and the load factor. The default load factor, I believe, is 75%. So in this one, if you just set the initial capacity, the load factor would be set to 75%. But for all practical purposes, I've never written code in 15 or 20 years that I really felt like I needed to pass in an initial capacity or load factor. Java does a really good job at handling this underneath the surface. So for that reason, we are just going to use this basic constructor, the default constructor, which takes in no parameters. Okay, so I have my map now, and what I want to do is down here I want to update this dessert count. Okay, so someone comes in and they type in cookies. Okay, so what do we want to happen? When they type in cookies, we want to basically put cookies into the array list, the map, with a value of 1, since in theory it's never been seen before. Okay, if we have seen cookies before, then we want to update it to 2 or something like that, like we see down here. We want to replace that value. Okay, so let's go ahead and take a look at how we can do that. Okay, so what we want to do is we want to basically check first, hey, have we ever seen this particular dessert before? Okay, so if we can say that dessert count, or that sorry, got the wrong variable there. If dessert count dot contains key, and then I pass in dessert. Okay, so what this will do is this will return true if that particular dessert that they entered in is in the map. Okay, so what I'm actually going to do is I'm going to say if it's not in the map, then what I'm going to do is I'm going to say dessert count dot put that dessert into the map with a count of 1. Right? If that key is not in the map, then I've never seen that key, so I'm going to just put it in with a value of 1, because surely this is the first person who's ever said that they like that dessert. Okay. Now, one thing at this point I do want to point out, well, I'll point it out a little bit later too. The reason that I did this to uppercase is because I want to protect against the user spelling cookies with a capital C or a lowercase c. If I actually go back to my demonstration here, if I put cookies in with a 1, it would put a row right here, right, just like you see. If the next line below it said m.putCookies, but cookies was all lowercase, it would actually put cookies in some other row with a lowercase c. So sensitivity of uppercase, lowercase is important with a map, especially as it relates to strings. So for that reason, typically when I use a map and the key is of the string data type, I will always force the keys to uppercase, so that way, regardless of how a user may type in a key using uppercase or lowercase levels, it's always going to map to the same row. Okay, so that was the case for when the key was not in the map. So this is the first time I've seen this dessert. Let's say that I've seen it before. So this would be the else case, right? In this case, what I'm going to do is I'm going to get the existing value that key is mapped to, that dessert is mapped to. I'm going to increment it, and then I'm going to put it back into the map. So we can do that by just creating a new integer, updated count. That's equal to mDessert count dot get. Okay, so the get is the keyword there. So I'm going to get that dessert count, which is probably going to be a 1 the first time, right? And then I'm simply going to add 1 to it, and then I'm going to put it back in. So I'll say mDessert count dot put, and I'm going to put it back in, put that dessert in at the updated count. Okay, now you can obviously optimize this code, fit it into 1 line, but just for the sake of readability and demonstration and teachability, I'm going to do this in 2 lines. Okay, so at this point our map is actually in pretty good shape. So what I want to do now is I want to actually come down outside of the while loop, and I want to print out all the desserts. So we just want to see that it's actually storing these desserts and the counts in the map properly. So let's go down to the bottom, and we'll go ahead and we will do a system.out.print line, and I'm just going to do maybe like a new line and then all desserts. Okay, and then I'm going to iterate through the key set. Okay, so essentially what's going to happen is when I call this command KeySet, what it's going to do is it's actually going to give me a set of all the unique keys. And then I'm going to iterate through these keys, and it's just they're gonna be out of order. It's not gonna be in alphabetical order or the order that I added them or anything like that. It's gonna just be in some seemingly random order. I'm going to iterate through all those keys, and then using those keys, I can get the value associated with that key. Just like we did right here, we got the value associated with dessert, the current value, and then we added a 1 to it to get an updated count. So how I can do that is I can say for string dessert in, using that colon, mDessert count dot KeySet. Okay. And from here, I'll go ahead and just do a print statement. So I'll say system.out.print. I'll do a printf here. And inside, the way that I'm going to format this, I'll do a tab. And then I'll do a %s. So this is going to be the dessert. So this dessert was chosen as a favorite dessert %s times. Okay. Then I'll end that with a new line. And so this first %s I'm going to replace with whatever dessert type we're looking at, we're iterating through. And then I'm going to use my map to get the value associated with this dessert, that count associated with this dessert. So I'll say mDessert count dot get dessert. Okay, so let's go ahead and give this a try now. All right, so please enter your favorite dessert. So I'll say cookies, say yes, brownies, yes, and let's do pie. Yes, now let's do brownies again. Yes, now let's do candy. Yes, candy. Yes, we really like candy. And I'll say no. Okay, so what we see is cookies was chosen as a favorite dessert one time, and that's correct, right? We only chose that once. Brownies was chosen twice. Candy was chosen 3 times, and pie was chosen once. Okay, so we do see that, in fact, our map is being updated properly. The initial values are put at the right time with the value of 1. And then anytime we update, you'll see it'll get the current value, it'll add 1 to it, and it'll put it back in there. Okay. Now notice it seems like it's kind of in order because we added cookies and brownies first. And you see cookies and brownies print out. But then notice it goes candy and pie, when in reality, we had entered pie and then candy. So it's just kind of a coincidence that cookies and brownies happen to print out first. That can be in literally any order. It's just kind of internally representing this in its own order. Okay, so actually don't need these curly braces here or here. Okay, so another thing we can do is instead of put, we can actually call mDessert count dot replace. And I can pass in dessert and updated count there as well. Okay, so this, what we're going to see is the exact same behavior with replace as we saw with put. The only difference is replace only acts if dessert key exists. Okay, so if you try to call replace on some dessert that didn't exist, then it's not going to do anything. Okay, so maybe let's actually just demonstrate that this does the same thing that we expect. So I'll say cookies, yes, brownies, yes, cookies, no. So we do see cookies was twice and brownies was once. So now what I can do, if I want to demonstrate that this replace, if I actually hard-coded some value like pasta. Okay, so this time you can see I'm just trying to replace pasta, but we know that we never actually added it, we never put it in there originally. So when I do cookies, yes, brownies, yes, pie, no, you'll see that you only see cookies, brownies, and pie. You never see pasta actually show up because you can't replace something that was never put in there in the first place. Okay. All right, so it's really up to you whether you want to use put or replace in this particular case. Replace is always safe here because we already did the check. We know that the key exists since we made it to this else statement, right? So key already exists. And since we know the key already exists, then replace or put are both basically going to do the same thing in this context. Okay, so I'll leave the replace there. It doesn't really matter. Okay, so let's take a look at a few other ways that we could do this same update dessert count map. So the second way that we're going to update this is using putIfAbsent and compute. Okay, and actually right before I do that, I want to demonstrate what happens if I don't to uppercase this dessert type. Okay, so let's say that I just put a semicolon here, and I just literally take in their dessert exactly as they see it. Okay, so in this case, I could type in cookies, yes, and then I could type in brownies, yes, and then I get a little bit lazy, I type in cookies, yes, right, then I type in cookies again, and then no. Okay, so what we see in this case, we get cookies was chosen twice, cookies with the lowercase was chosen once, brownies was chosen once. So this is technically correct, but this is almost always not what we mean to do, especially when we have strings as the key. So in this case, you just want to make sure that you always do the to uppercase. Okay, so now let's look at another method for updating the dessert count map. So I'm going to go ahead and comment this little section out. And in this next method, what I'm going to do, get a little spacing down here, move this code up for us. In this one, I'm going to use a putIfAbsent and compute. Okay, so in this case, you'll see the code's going to be quite a bit simpler. What I can do is I can say dessert count dot putIfAbsent, and then I'm going to pass in my dessert and 1. Okay, so this is basically internally within this method, it's essentially doing this if statement right here, right? Because that's exactly what we did. We said, hey, if this key is absent, right? If this key is not contained in the map, this dessert is not contained in the map, then put it. So you can see we just kind of have this one nice method to wrap that if statement. So we're going to put it if absent, and then we are going to call a method, a compute method, unconditionally. So we can say dessert count.compute. Okay, now compute is a little bit more interesting. Okay, so compute takes in two parameters. It takes in a key, and then it takes in what I would call a lambda expression. It takes in a method instead of some traditional data type. Okay, so what I'm going to do is I'm going to say, hey, if I get this dessert type, I'm going to call a method. Okay, and this method, this uses a lambda expression, and the syntax is a little bit weird. The syntax essentially goes like this: parameters, then I have this little arrow, and then I have some method to call. Okay, so some method to call or some line of code to call. Maybe I'll say that, like some code to call. Okay. So in this case, what I'm going to do is for my parameters, now this is just a given. If you hover over compute, you will see, you should see basically this by function. This is talking about the function, that lambda expression that it's expecting as that second parameter. You can kind of see if you wade through a lot of the notation here that it wants two parameters, a string and an integer. And that maps exactly to our map data type, the string and an integer. So that'll change depending on what our particular map type was. So all this really is it's saying, hey, I'm going to call this method and I'm going to have access to the key and the value. Okay, so I'm going to pass dessert, right? Whatever dessert is, I'm going to get, in some sense, I'm going to get that row for the particular dessert, and then I can call some method with the key and value for that particular row. Okay, so the method that I'm going to call is just simply to increment the value, whatever that value is. Okay, so again, if I called let's say I called compute m.compute pi. All right, what it's going to do is it's going to go find the row with pi in it. Okay, and then it's going to say, all right, well, the key is pi and the value is 1. So I'm just going to go ahead and increment that value of 1 to 2. Right, so that's exactly what's happening. This is my lambda expression. I have those parameters getting passed in, and then that's on the left side of the arrow. On the right side of the arrow is the actual code that I'm going to call, and I have access to these particular parameters in this expression. Okay, and that's actually it. So you can see our code is pretty simple compared to the code that we had up here. Okay, so let's go ahead and run it and just make sure that it works. So we'll say cookies, yes, brownies, yes, cookies, yes, cookies, no. Okay, so we have a little bit of a problem here. We see that we entered in cookies 3 times and we entered in brownies once. Okay, so what's the problem that we have? So the problem that we have is we actually initialize this putIfAbsent to the wrong value, right? So if it's absent, you can see that no matter what, we are going to unconditionally increment the value. So if it's absent, what we actually want to do is we want to initialize it to 0 to say, hey, we've never seen this dessert, but we're going to put it in the table as a value of 0, and then unconditionally we'll increment that 0 to a 1. Okay. If it's not absent, right, if that dessert is in the database or in our table, maybe it has a value of 2 already, we're not going to update it at all. We're just going to go ahead and then call this compute to increment it from 2 to 3. So let's go ahead and run this again. So now we'll try cookies. Yes. Oops. Let's do that again. Say cookies. Yes. Brownies. Yes. Cookies. Yes. Cookies. No. Okay, and this time you see brownies was 1 time, and then cookies was 3 times. Okay, so we've successfully reproduced these 1, 2, 3, 4, 5, 6, 7 lines of code with just 2 lines of code. So from a code perspective and cleanliness of code, so to speak, organization of code, that's a lot cleaner to implement it that way. Okay, so that's a second method, basically teaching you the putIfAbsent and the compute methods. So there's one more way that I would kind of think would make sense to do this, and that's using the computeIfPresent and the computeIfAbsent. Okay, so what we are going to do here is we are going to essentially, so I just commented out the method 2, and now we're going to move to method 3. So I'm going to say m_dessertCount dot compute if let's just say absent. Okay, and in this case I'm going to pass in a dessert, and I am going to actually take in just one particular parameter. So you'll see, again, following this format, params, and then my method or my code would go here. Okay, so in this case you'll see computeIfAbsent, it actually only takes in one parameter, and that's just a string. Okay, so you'll see, and that string, it's really the key. Okay, so it takes in the key, and what we are going to do with the computeIfAbsent is I'm basically just going to say 1. Okay, so basically, hey, I'm going to, if the key is absent, then I'm just going to set it to the value of 1. And then if this dessert count, I can say computeIfPresent. Okay, and this is going to be very similar to the original compute, where it takes in a key and value, and then we're going to map that to a line of code which essentially says ++ value. Okay, so this is going to be exactly the same as the compute above, right? With the compute above, we knew that it was present because we just put it in there if it was absent. We knew that this key was present because we just put the key in there if it was absent with the value of 0. So these methods are just 2 different ways you could do this, right? If dessert's absent, then I'm just literally going to set it set the value of that key to 1. If dessert is present, then I'm just going to increment the value. So again, let's run this one more time. This time we'll say pie, yes, brownies, yes, pie, yes, candy, yes, pie, no. Okay, so we see, I think I did the same mistake here. Let's see, what do we do? So sorry, I did these in the reverse order. So essentially, what's happening with this code is it's running through and it says computeIfAbsent. So if this dessert is absent, it adds it in with a value of 1, and then immediately it sees that, hey, this dessert which was not here is now present, so it increments it. So that's why all of our counters are up by 1. So what I should do is I should actually put the present computeIfPresent first. Okay, so if it's present, then it'll increment it, and then if it's not present, it'll come down here and it'll add it in with a value of 1. So the order of those two statements are important in this particular, the way that we're using this code. Okay, so I'm going to say favorite dessert. Let's try that again. Pie, yes. Cookies, yes. Pie, yes. Pie, yes. Brownies, no. Okay, so now we get pie 3 times, and then cookies and brownies 1 time. Okay, so 3 different ways to do the exact same thing. It's really up to you. I just wanted to demonstrate all the different methods, the compute methods and the put methods, as well as the replace method. Okay, so you can leave any of these 3 methods uncommented. Either one's fine. I'll just leave this last one since it's what we were working with most recently. And then I'm going to jump down. I'm going to prompt the user to get a certain dessert count. Okay, so I'm just going to ask them to pull up one specific count for a dessert. Okay, so what I'll do is I'll do a system.out.print, and we'll say something like this. We'll do a new line character. We'll say please enter a dessert to see the number of people who have that dessert as their favorite. Okay, so we'll just leave it at that. Please enter a dessert to see the number of people who have that dessert as their favorite. Okay, and from there I can go ahead and I can say string dessert is equal to scan.nextLine to read in whatever they type in, and then I'm going to go ahead and force that to uppercase. Okay, and from there what we need to do is simply get that count. So I can say int count is equal to m dessert count. So we're going to grab that map dot get, and we just simply pass in the dessert. So that will return the count, and then that way we can print this result back out to the user. So we'll do a system.out. We'll do a printf, and maybe I'll format it like this. I'll do a tab with the %s, so I'll say %s individuals, like %s, whatever that dessert is, as their favorite dessert. And then I'll put a new line at the end there. Okay, so that first %s I'm going to replace with the count, and the second one I'm going to replace with the dessert. Okay, so let's go ahead and give this a try. So I will do cookies, yes, pie, no. So please enter a dessert to see the number of people who have that dessert as their favorite. So I'll do pie, and you can see 2 individuals like pie as their favorite dessert. Okay, so let's continue on. But let's actually, before we continue on, let's make this code just a little bit more flexible. Okay, let's say that someone actually ran through this program. So we did pie, yes, cookies, and then no. And then we say, please enter a dessert to see the number of people who have that dessert as their favorite. Let's say that we then typed in candy. Okay, and we get this null pointer exception. Why is that? Well, it's because we're basically, candy is not in the map. So when we go to read candy, it's just not going to actually read anything. You'll see that, or it's not going to return anything. So you can see we get an error on line 69, which is basically when I try to get that particular row. There's nothing there. Okay, so what we can do is we can actually, there's another method, there's a getOrDefault. So I can call this getOrDefault method, and it takes in two parameters. It takes in the key and then a default value to return. So essentially what I'm going to say is I'm going to say get the dessert count, but if there is no dessert count for that dessert, then go ahead and just return 0. Okay, so this will make our program a little bit more flexible in this case. So please enter your favorite dessert. I'll say pie, yes, cookies, no, and then now if I type in candy, you'll see 0 individuals like candy as their favorite dessert. So just with that little upgrade to our program using that getOrDefault, you'll see that we've made our program a lot more flexible, and it's not going to end in an exception, at least in that particular case. Okay, so now let's go ahead and we'll prompt our user to remove their favorite dessert. Okay, so what we're going to do is we'll say system.out.print, and we will do a new line just for formatting purposes. We'll say please enter the dessert you like the least so we can remove it from the list. Okay, so then I already have this dessert variable declared. I don't really need the pass value, so I'll just say dessert equals scan.nextLine dot to uppercase. Okay, and then I can just say mDessertCount.remove dessert. So what it will do is it will find the row that corresponds to that particular dessert, find that row in the map, and it will literally remove the whole map. Okay, so in order for us to determine that that's working, let's go ahead and print out the contents of the map one more time. Okay, so what I will do, I'll just go ahead and kind of copy our print statement from up here. Okay, so all desserts, and this time I'll just add a little bit of an extra tag, updated after removal. Okay, so in this particular print statement, when I'm iterating through, I'm going to use the actual iterator. Okay, so let's see how we use the iterator for the map. Okay, so what I need to do is I need to start off by creating, well, I could typically, let's actually use the map and let's see what it is expecting. So mDessertCount dot, what I need to do is grab the entry set. So this is going to grab me all the entries, which is essentially the key value pairs, dot iterator. Okay, and what is that returning? You'll see if you hover over, it's expecting an iterator with an entry of data types string and integer. So if you want, just kind of easy, you see what Eclipse is expecting, but we'll go ahead and type it out from scratch, but that's essentially what it's expecting. No, never mind, I was able to copy it. So that iterator, entry, string, integer, right? So iterator is iterating through a number of entries, right? Each entry is a row which just has a string and an integer. That's the key value pair. So I will call this like IT desserts. Okay, so for iterator for the desserts. So I do need to import iterator from java.util, and then I do need to import entry from java.util.map. Okay, so that just added to the top here. It added this entry in this iterator, java.util.iterator and java.util.map entry, map.entry. Okay. So then what I can do is I can just do a while loop to iterate through each of these entries. So while it desserts dot has next. So while there's another row, what I'm going to do is I'm going to go ahead and just grab that entry for that particular row. So that entry is of a string integer key value pair. So I'll say the entry string integer, and I will just call that, I'll call it maybe like dessert entry or dessert row or something like that. and that's equal to itDesserts dot next. Okay, and then from there what I can do, I'm just going to go ahead and keep the same formatting for all my for loops. So I'm going to go ahead, or my when I'm printing out my map contents, so I'll go ahead where I printed out all the desserts and I'll copy that line and I'll paste it right here. Only difference is instead of dessert in the dessert count, what I'm going to pass in this time is the dessert entry dot get key and the dessert entry dot get value. Okay, so remember the entry is just a key value pair. It's almost like I'm literally returning like an entire row. So it's like returning this brownies one pair, so I can get the key portion of it and I can get the value portion of it. So let's go ahead and run this. So we'll see, let's see, cookies, yes, brownies, yes, brownies, yes, and then, you know, someone else's favorite dessert is pasta. So I say no. So cookies one time, brownies twice, pasta one time. Please enter a dessert to see the number of people who like it. So let's do brownies. So 2 individuals like brownies. And then I can say, all right, well, pasta. I don't really like pasta. Let's go ahead and remove that from the list. So now you can see my updated list just has cookies one time and then brownies 2 times. And you can see pasta is completely removed from the list. Okay, so that's great. So the last thing I want to do is I want to make a copy of the desserts into a new map to show you that functionality. And then we will iterate one more time using the forEach method of the map. Okay, so to do that, let's go ahead and create a new map. So we'll say map string integer. So again, mapping desserts to counts. And we'll call this mDessert count2. That's going to be equal to a new hash map of string and integer. Okay, so this is literally the exact same way that we initialize this original map. Okay, but there's one method that I want to show you, and that is the putAll method. So what I can do is I can say mDessert count2 dot putAll, and then I simply pass in this existing map. And essentially what this is going to do is it's going to make a copy of mDessert count into mDessert count2. So it's literally going to copy every single one of these key value pairs, and it's going to place them within this new map. Okay, I can also do this same exact thing through the constructor as well, by the way. So I could pass in mDessert count like this, and this is going to have the same exact impact as the 2 lines which I just commented out. Okay, so I'll go ahead and put that one up top. I'm going to comment it out because I want to show you the putAll method. I think that's pretty common that you'll see if you pass something into if you pass like a data structure into a constructor, that it'll basically make a copy of it. So I want to specifically show you this putAll, but again, this line constructor does the same as the 2 lines below. Okay, so let's demonstrate that this worked by writing one final for loop. And so in this for loop, I'll go ahead and I'll print out my system.out.print. Okay, so this is going to be all desserts, but this is specifically going to be iterating through the copy. Okay, and what I'm going to do here is I'm going to say mDessert count2 dot forEach. Okay, so notice this should look a little bit familiar. You kind of see this by consumer, whatever type of stuff that you maybe saw earlier when we were working with the compute method, if you were really paying attention to what was popping up in Eclipse. This forEach, the way that it works is it basically takes in, it's expecting a lambda expression, so it's expecting a method. And the particular method that it is expecting has 2 parameters. Okay, it has a key and a value, and that maps to some method or some code, right? Like this. Okay, so for each key value maps to, and what I'm actually going to do for this, I'm going to again go ahead and copy this system.out.printf line, and I'm literally going to paste it in over top of that code. Okay. And what we see here is this is just going to simplify, because now I have key and value in the context of the right hand side of this expression. So I can literally just put key and value. Okay, give this a little breathing room so you can kind of see what's happening here. So what's really neat about this forEach is it's basically going to iterate through every single key value pair, and then it's going to run this line of code for that key value pair. So you'll see it's going to have the same exact functionality as I saw before. And do note that we are iterating through that dessert count 2. So if I run this, you'll see favorite dessert, cookies, yes, brownies, yes, brownies, yes, pasta, no. Okay, so please enter dessert to see. Let's try candy. 0 individuals like candy, so our getOrDefault method is working properly. Please enter the dessert you would like the least, so I'll do pasta. So you'll see all desserts updated after removal, just cookies and brownies at 1 and 2, and then my all desserts copy, brownies and cookies 2 and 1. So again, you'll see very clearly that there's really no order when we made the copy to copy mDesserts count into mDesserts count 2. You'll see very clearly that when we printed them out, they printed in a different order. Okay? All right, so that's great. So we've gone through a lot of practical code with the hash map. We talked about how to use the constructors, the put methods, the get methods, the compute methods, as well as replace, remove, ContainsKey, and KeySet. And then we looked at 3 different ways to iterate through all of the key value pairs. So the last thing to really discuss is when do you use hash maps? Okay, so typically, if you need any type of order to your data, I would not recommend a hash map. Now, there's ways to kind of hack it together, and you just have to do a little bit of extra work at the end. But typically, if you really need order to your data, whether you need alphabetical order to print through alphabetical order, or increasing numbers or something like that, and you know exactly how many items you need to use, then probably arrays is what you want to use. If you need order and you don't know how many items you're going to need, if you're going to keep adding items from the user will keep adding items to your array, then array lists or linked lists are probably better just because they're dynamic in size. If you don't need order, okay, then we can move down to the sets and the maps. So if you don't need order and you need to know containment, so if some item or value exists in a set or category, then sets are really good for that. If you just need to know, hey, is this in group A or group B, then sets are extremely fast and efficient. However, if you don't need order, but you also need to map one arbitrary data type to another, like we just saw in our example, or you need to quickly search for keys, then hash maps is really the best option for you. So I almost, typically if I want to search for things very, very quickly, what we'll see is hash maps are extremely fast. You really can't get much faster than a hash map for searching. And I put a little asterisk right here. Some map implementations are ordered. So do recall, if we looked at our code again, when we initialized our map, we said map equals hash map. So map is the abstract class, and then hash map is a particular implementation. So what we can see is there's actually a number of different map implementations. These are just 3 of the most popular implementations. So there's hash map, tree map. I've used both of those in practice, and then there's a linked hash map as well. So you can see they have different implementation, different access speeds, and then orderings to them. So for a hash map, you can see it's ordered in this kind of table or buckets. You can think of each row. Let's bring that back. You can think of each row as like a bucket, so to speak. That's the term you'll actually see on Java's official documentation website. The amazing, amazing, amazing thing about a hash map is this right here. If I am searching for an item in the hash map, it's like I only have to search for one item. So let's think about an array list. Let's imagine that I had an array list of 1,000 strings. Let's actually make it bigger. Let's imagine that I had an array list of 1 million strings in it. And I just simply ask you the question, hey, is the value Dr. Dan, is there a string Dr. Dan somewhere in my array list? What would I have to do? I would literally have to look through each of those 1 million strings to determine that it was or wasn't in there. Now maybe I get lucky and it's in the very first one. But let's say that Dr. Dan actually wasn't one of the strings in the 1 million strings in my array list. I would literally have to look through 1 million strings to find out that it wasn't there. With a hash map, if I had 1 million entries in my hash map, it's like I always guess right the first time. I only have to check one value. And if I check that one value, I essentially know that, hey, Dr. Dan was not in there. So you can see the time savings is huge. What you'll see is the tree map has a little bit of a trade-off here. So it actually has a log of n, where n is the size of the array. Okay, so let's imagine that I had, let me bring up a little calculator for you. Let's imagine that I had 1 million items. Okay, I had 1 million items in my tree map. Okay, well, if I had 1 million items in a hash map, it's basically like I only have to search one of them to determine that a value is not in that map. If I have 1 million items in an array list, I have to search 1 million items to determine that that item is not in the array list. If I have 1 million items in the tree map, I can basically take the log of this. So in this case, it's like I only have to search 6 items to determine that that item is not in the map. So you can see 6 is much, much better than 1 million, but not quite as good as 1, like a constant 1. So what's really neat about this hash map is as the size of my map increases, it doesn't take me any longer whatsoever to actually search for values and to access certain key value pairs in the map. So you can see the implementation. A tree map uses a tree, a red-black tree specifically, as you would guess from the name of the data structure itself, tree map. One nice advantage of the tree map is there is a natural ordering of keys. So you actually can order them alphabetically or something like that. But you can see it wasn't quite as fast. It's not quite as fast to access and search. There's also the linked hash map, which uses a combination of table and a doubly linked list. That also has a really fast access speed of 1, just like the hash map. And it has this some kind of odd ordering, an order of insertion. So it actually orders it based on how you inserted items. So if I added cookies, brownies, and candy, I could actually get that same order back when I iterated through, which may or may not be useful. I find typically the order in which I add things is not so much useful. It's typically just the natural ordering, whether it's alphabetical or by increasing number, something like that. So if for some reason that order of insertion is important, this may be a good map implementation to go with, the linked hash map. Do note that obviously anytime you get something extra, the order where we didn't have the order with the hash map, there is going to be a little bit of a bigger memory footprint than the hash map. I will say in practice, I almost always use the hash map. I would say I actually always use the hash map because there are other ways to get the order back if you really, really need it. But for the most part, this speed and the small memory footprint is really the #1 thing that you're looking for when you're seeking to map some arbitrary data type to another arbitrary data type. So if you're not sure which data structure to use, it's probably the hash map. Unless you really, really need the ordering, the natural ordering, then the tree map would be a good way to go. All right, so I hope you enjoyed this video. If you did, be sure to smash that like button and subscribe to the channel. We've got some really cool stuff coming up. Thanks.